What's up guys, welcome back to another video here at Chief Academy, and today we'll be going through sequences and the nth term. Please like and subscribe and stick around to the end because I promise you it is this easy. In today's lesson we want to understand what the nth term stands for and knowing the main sequences and solving sequences for the nth term. In maths, the nth term refers to a placeholder value that is used to find the next value in the infinite long list of a sequence. In this lesson, we will focus on solving for the nth term, understanding the basics of the Fibonacci sequence, and solving simple nth term quadratic sequences, as quadratic sequences are more a grade 7 skill later on. So, what is the nth term? The nth term refers to a term position in the sequence. For example, the first term has n equals 1, and the second term has n equals 2, and so on. An expression for the nth term is worked out by looking at the difference between the terms of the sequence and comparing the sequence to the appropriate timetables. As you can see, we have a term of values such as 2, 4, 6, 8, 10, and the normal n values of 1, 2, 3, 4, and 5. In our term, the difference between each term is plus 2, so we simply say our n is 2n, as it is a duplication of the normal n values. If our terms go up in the same amount each time, it is called a linear sequence. Such that our terms here, it is plus 2, plus 2, plus 2, and plus 2. It is a linear sequence. In your exams, if you get asked a linear sequence and you see a quadratic and you're working out, you've done something wrong, because a quadratic sequence is not a linear sequence, as they are two separate things. Once again, here are some exam practice questions from Maths Genie, with a link down below. Have a go, pause the video, and unpause. So, question 1, it says, here are the first 5 terms of the sequence, 2, 4, 7, 11, and 16. Write down the next 2 terms in the sequence. As we look at the differences of each of our terms, we can see a pattern. First term, plus 2, second term, plus 3, third term, plus 4. Each term is plus in 1 more than the original value. So, 11 to 16 is plus 5, so we must then plus 6 in our next one. So our next one would be 22, and then plus 7 to 22 to get 29. So our answers would be 22 and 20. In question 2, it states, the first term in the sequence is 3. The term-to-term rule is add 5. The question is 97 a term in this sequence? And you must give a reason for your answer. The way we would start to answer this question is to write down the first 5 terms of the sequence. Here, first term is 3. Then we plus 5 to get 8, plus 5 to get 13, plus 5 to get 18. Here we can see a pattern. Each term ends in either 3 or 8. And as our number is 97, it does not end in a 3 or an 8. So our answer is no, and our reason is because each term in the sequence ends in 3 or 8. In maths, the Fibonacci sequence is a sequence in which each number is the sum of the 2 preceding numbers. Numbers that are part of the Fibonacci sequence are also known as Fibonacci numbers. For GCSE at around grade 4, you're supposed to know the basics of the Fibonacci sequence, but not the full diagrams that you would later on, maybe grade 8 or 9. So, as we can see, the original Fibonacci sequence here is 1, 2, 3, 5, 8, 13, 21, 34, and so on, so on. As you can see by the working out, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13, and so on, so on. And this, you'll probably be asked to answer one of these in your exams, and they're probably worth like 1 or 2 marks. Here are some more exam questions to have a go at. Have a go, pause the video, and unpause. So, example 1 states, here are the first 5 terms of a Fibonacci sequence. Write down the next few terms in the sequence. As we can see, it's the original Fibonacci sequence, what we've just been through. So our simple answer would be just 13 and 21. Our second question also says, here are the first 5 terms of the Fibonacci sequence, but is not the Fibonacci sequence, but it still follows the same principles and rules as the original. We are asked to find the 8th term of the sequence. So, as you can see, 2 to 2 is a 0, but then if we plus 2 and 2 we get 4, 2 and 4 we get 6, 6 and 10, and so on, so on. And these are our first 5, so we must do this 3 more times. So, 6 plus 10, 16, 10 plus 16, 26, 16 plus 26 equals 42. So our answer would be 42. Here now are some of the hardest questions you'll probably be asked at grade 4 level for nth term and sequences. Have a go, pause the video and unpause. So, our first question says the nth term of a sequence is n squared plus 3. Find the first 3 terms of the sequence. As we have a square, we simply just square our nth term. So, for the first one, we square 1 plus 3 to get 4. Our second one, we square 2 to get 4, plus 3 to get 7. And then we square 3, which is 9, plus 3 to get 12. So that is our first 3 terms of our sequence, 4, 7, and 12. Part B, we're asked to find the 10th term in the sequence. So we simply sub 10 into n. So 10 squared plus 3 equals 100 plus 3 equals 103. So our final answer is just. Our second question says, here is a sequence of patterns made from grey counters. Part A asks us, in the space below, to draw pattern number 4. If we look at our pattern number 1, we can see it has 5 counters. If we look at pattern number 2, we see it has 9, and number 3 has 13. If we look at the difference between each pattern, we see we're going up by 4. So, 13 plus 4 equals 17. So our pattern would look like this if we simply added another 4 to our sequence. In part B, we are asked to work out the total number of counters to make pattern number 10. Here, we look at 5, 9 and 13, and then we find out our nth term of the sequence. It would be 4n plus 1, because our linear is plus 4, so that is our 4n, and we get from 4 to 5 plus 1. To get from 8 to 9 is plus 1. So, we simply sub in 10 to our n, so 4 times 10 equals 40, plus 1 equals 41. So our final answer of this question would be 41. And that, ladies and gentlemen, is the end of today's lesson on sequences and nth terms. And I did say, it is that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I will see you in the next one.